Morning students, this is Murthy Sir. Today you will learn about an interesting topic, carbon and its compounds. Carbon is a very important non-metallic element which belongs to 14th group in the periodic table. It belongs to P block. The electronic configuration of carbon is 1s2, 2s2, 2p2. When an electron from 2s orbital, it goes to 2p orbital, that is from ground state to the excited state, 4 electrons will be available in the outermost shell. That is why carbon is tetravalent. In this picture, you can observe the movement of electron from 2s to 2p orbital, from ground state to the excited state. Carbon is a versatile element and is found in many different chemical compounds, including those found in space. Carbon is versatile because it can form single, double, and triple bonds. It can also form chains, branched chains, and rings when connected to other carbon atoms. Vital force theory. It is also known as bioforce theory. It was proposed by great scientist Zeze Berzelius in the year 1808. Therefore, he is known as father of organic chemistry. According to him, we cannot prepare organic compounds in the laboratory. Friedrich Hohler, student of Berzelius, disproved vital force theory when he accidentally prepared urea in the laboratory when he heated an inorganic salt called ammonium cyanate. The Hohler synthesis is the conversion of ammonium cyanate into urea. This chemical reaction was described by Friedrich Hohler in the year 1828. The synthesis of urea from inorganic salt in the laboratory by Friedrich Hohler was a significant step in the field of chemistry. Here you can observe the chemical reaction. Ammonium cyanate, when it was heated, it forms an organic compound called urea. Urea, an organic compound, is the main nitrogenous waste in our human body, which will be expelled by nephrons. In organic chemistry, we come across some compounds which have similar number of atoms but differ in physical and chemical properties, and these are called isomers. And this phenomenon is called isomerism. Isomers have same molecular formula but differ in arrangement of atoms within a molecule. Ammonium cyanate and urea are isomers. They have similar molecular formula but different structures and different properties. Ethyl alcohol and dimethyl ether are functional isomers. They have similar molecular formula but different structures and different properties. N-pentane, isopentane and neopentane. These three are structural isomers. They have similar molecular formula but different structures and different properties. As carbon possesses atomic number 6, it means that carbon atom has a total of 6 electrons. Thus carbon is tetravalent and can form 4 covalent bonds with not only other atoms but other carbon atoms as well. This is called tetravalency of carbon. Catenation is the linkage of atoms of the same element into longer chains. Catenation occurs most readily in carbon, which forms covalent bonds with other carbon atoms to form longer chains and structures. This is the reason for the presence of vast number of organic compounds in nature. Catenation is the binding of an element to itself through covalent bonds to form chain or ring molecules. Carbon is the most common element that exhibits catenation. It can form long hydrocarbon chains and rings like benzene. In proteins, millions of carbon atoms are bonded to one another. Hydrocarbons are organic compounds that are made up of only hydrogen and carbon atoms. Saturated hydrocarbons have only single bonds between carbon and hydrogen atoms and are called alkanes. General formula is CnH2n plus 2. An example is ethane, C2H6. An unsaturated hydrocarbon is a hydrocarbon containing at least one double or triple bond. An alkene is a hydrocarbon containing double bonds. The general formula for alkenes is CnH2n. An alkyne is a hydrocarbon containing triple bonds. The general formula for alkynes is CnH2n minus 2. Homologous series is a series of compounds with similar chemical properties in which members differ from one another by additional CH2 group. In this picture, you can see some examples of homologous series: alkanes, methane, ethane, propane, butane, and pentane. Here, from methane to pentane, the successive compounds differ by a CH2 unit.